So here's an overview of the system. Got the wind turbine spinning the pulley that's turning this. There's the hub generator. The wires coming out. There's two wires. There's the 3-phase from the generator itself, and then I've got 3 wires coming out from the Hall effect sensors. So there's positive, there's negative, and then there's the Hall effect sensor itself. Then I also have an anemometer, and that gets 1 dry contact every revolution. It's just got a magnet and a Hall effect switch, or not a Hall effect, but a reed switch, and it makes 1 contact every revolution. I put a repeater for our router in our garage, and that way we can get a signal that's pretty close to where the wind turbine is, so that way you can get our Wi-Fi out over there. Alright, in here we've got this buck boost input voltage controller. I've got the 3 phases coming from the generator. The output goes to the input of this windmill charge controller. I'm just using 2 of the 3 phases. It's all got a bridge rectifier in there, so I'm just doing it DC. And then I've got a signal coming off from this controller. There's an analog output from the digital to analog converter, and that just feeds my control signal. There's a ground signal, and this is what tells this what voltage to set its limit at, how it's controlling it. Alright, then the Hall effect switch comes in here. I've got a transistor kind of as a buffer. Okay, so I've got the positive coming in, negative, and then the yellow is the Hall effect switch. And then the connector going to the controller is just on the collector of this transistor. And I already blew out 1 pin, and that's why I decided to go with this extra step of putting a transistor in, because I tried putting this yellow pin directly in, and it ended up blowing out a pin. At least I think so. These pins are configured as internal pull-up resistor. Okay, then the anemometer comes in here. Also has a similar setup. We've got a 10K resistor going from the positive to the base, and then we got the emitter connected to the ground. The anemometer is connected across the base to the ground, so when the switch closes, it lowers the voltage on this base down to 0, so the transistor turns off, and so this gives a high signal to the controller. Okay, this controller is powered via this USB cable on this solar charge controller. So that's what's powering this board. Alright, this is a MKR WiFi 1010. So it has Wi-Fi connection, and that connection goes to the router that we saw in the garage. And what this allows me to do is it allows me to take a portable device like this iPad, okay, and then we can, if we can get someplace where there isn't some glare. There's glare there too. Alright, how about we go like this? Alright, so you can configure a dashboard, and this dashboard is telling us wind speed. It's calculating the tip speed ratio. This is all being calculated on that little controller board and broadcast to the Arduino Cloud. And then we've got a control signal here. That's the signal that's going to the digital analog converter. And we can set a target tip speed ratio, so I can put that in increments of 0.5. I don't know why it has all these extra digits on there. And then I've got another control here, mode select, so I can select that. And if I select that as off, I turn off the control calculations and I can just adjust the control signal manually. So I can set it wherever I want from, normally it would go from 0 to 1023, but I didn't want to go too low and I didn't want to go too high, so I limited it to 80 to 800. But I can set that manually, and just try to do things manually here. So anyhow, this gives me wind speed in meters per second, and I think it's fairly accurate. It's filtered, so it takes a little while. This thing updates every 10 seconds. I've only got the free account with this right now. So anyhow, this gives me wind speed, and this gives me the current tip speed ratio for the wind turbine. And so I can just turn this back on and it calculates a control signal for me. But for some reason it's always going down to 80. I'm not sure why. We've got some more debugging to do apparently. So there's still a few problems with this system. Another thing is I have yet to see this thing produce any power, and that's puzzling me because I can measure the voltage on here. Okay, so I can measure the voltage and I'm getting 14.7, 14.5. And you'd think that that would charge the battery. I suspect this is at 13.82 right now. It's possible that the battery is fully charged and it's just not allowing any more in there. I'll have to drain the battery some and try it again. So that's one thing. And the other thing is if I measure this across here, okay, I'm just getting 3 volts or so. So I'm not getting too much input voltage, but I think that's partly because the controller is dropping it to the number going to the digital analog converter is only 80. And so I think it's trying to bring this voltage down. Maybe because the wind turbine has a little too high tip speed ratio, and this thing is trying its best to slow it down by dropping the control signal. However, this thing is not accepting any more charge, so I'm guessing that's what's happening. Anyway, I'll be playing with it some more. Everything is programmed through the Arduino Cloud. You can use an IDE, but I've been using the Cloud. And what you can do is you can have a device. I think you can have up to 2 devices with a free account. And so I've got just the one. It's the MKR WiFi 1010. Then you can define a thing, and you kind of do this in order. And here what you can do is you can give up to 5 variables. This is for the free account. 5 variables. You give them names and variable types like float, boolean, integer, whatever you want. And then those are the variables that will be shared between the internet and your device. We'll see that in just a little bit. And then you can go to dashboards. This is the interface between those variables. This is what we saw in the iPad 2. So you can interact with variables like the target tip speed ratio, and you can just, this will be all handled on the fly. I mean, it will just automatically transfer it over to the device, although right now I don't think it's connected to the internet. Maybe it is. I'm not sure if I can get internet through that box that it's in. It's in a steel enclosure, so I'm not sure if it's talking to it right now. It doesn't look like it is. So anyway, you can set up a dashboard where you can play with those variables. It's really not so hard to change this. You just go to edit. You can add push buttons, scheduler values, all kinds of different things. You just pick it, and then what you do is you give it a name. You can link it to one of those variables that we had. Right now it just links to Boolean variables, and I just have one. So anyway, and then if you go done, there's your new tab or whatever on your dashboard. I'm just gonna delete this because I don't want it. Okay, so just go done. And then as far as programming is concerned, just go to here, go to sketches. I've just got the one sketch. So I go here, and here's my sketch. Just close that down. So initially what Arduino does in the cloud is they have this things properties.h. This is something that their software generates. So you don't edit this, but it gives all those variables that we just talked about, and then it says it's it just has initialization of the properties, if it's read write or just read only, how often it updates, maybe on change, and then it's got some subroutines that it calls if it does change. And here's the software that I generate. So define some variables, set up a serial monitor, initialize the properties, starts to talk to the cloud. This is where you give it the password to your router and that sort of thing. It doesn't tell you, or it keeps some of that stuff secret, so we don't see passwords. Let's see, debug info, that's nothing. Okay, here are the pin mode things, inputs with a pull-up resistor, LED is built in, that's an output. Here's my analog output. And I attached a couple interrupts to falling edges of these pins, and this is the routine it calls when that happens. I'm not a computer scientist, so I don't know all the lingo. Anyhow, some more variables. This is the loop that loops forever. Every time it comes to the top of the loop, it goes to the cloud and it updates those variables. So that's when it does its communication to the cloud and updates things in real time. So every loop it changes. So every 2 seconds, well, for 2 seconds I count pulses on the anemometer and the wind turbine. So it calls every time there's an interrupt, it jumps to this subroutine here, increments an anemometer pulse, and increments a turbine pulse when that pin changes. It's got a little debounce thing on there, so that if the time between pulses is too low, it means there is some bouncing going on, and it just ignores the increment. Anyway, it just kind of does that in the background. And for 2 seconds, or after 2 seconds, it stops the interrupts. It just takes that pulse count and then resets the counter. Same with the turbine. And so I can calculate wind speed using the conversion factor given in the data sheet for the anemometer and with the wind turbine. And I filter it a little bit. I put like 80% of the previous value plus 20% of the new value, just so that it doesn't jump around too much. And then we can calculate tip speed ratio. I just double check to make sure wind speed isn't less than 0 or equal to 0 basically, so you don't get a division by 0 error. And I make sure it stays between a couple practical values. I just don't want it messing things up with some outrageous value for some reason. Then every 500 milliseconds I calculate a control signal. So let's see, 500 milliseconds, I calculate the error between the target tip speed ratio value and what I'm actually getting, and I integrate that error. And I put limits on the integration so I don't get wind up. And then I've got that button, so if it's in a positive state, then it will calculate the control signal and make sure it stays between limits. That's why it was showing 80 all the time, because it was going too low and it just kept going to 80. But if it doesn't, if this is false, if mode is false, then it takes whatever value I give it from the iPad or the computer or whatever. And then it outputs the control signal to the DAC, and it changes the state of the LED. So anyhow, that's the control signal. And that's pretty much it. This is back to counting the pulses. And then this is some code that's generated by Arduino when you set it up. So it does some debugging if you want to. You can just kind of leave it or delete it, whatever you want. So anyhow, you can verify it. If for the free account, you have to have your device connected to the computer to upload it. If you have a premium account, you can just upload it over the web. So that's the code I'm running.